Well, first of all, thank you very much for the organizing committee. It's a pleasure to be here in this fantastic country. It's my first time in the forum. I am a researcher from Aarhus University in Denmark, also affiliated with the Greenland Institute of Natural Resources. And I am going to provide here a slightly different angle because I am a data user. So I'm going to be focusing on slightly different things with a special emphasis on spatial gaps analysis, both in polar domains. I'm going to be talking a lot about recent work, primarily in the north, in the Pan-Arctic region. And also I'm going to be flagging one of the projects that we are currently working on that is building up on what Dan has presented, the Polarin project. And I hope also to get a bit of exposure to Antarctic domain so that I can include data from here in similar analysis that I'm going to be presenting. But first of all, I'm going to be talking about a paper that we published a year ago, where we try to understand how representative is our view on Arctic change. So we question whether we have a biased view on Arctic change, including the entire Pan-Arctic region, but also we have a look what happens if we remove all the sites from Russia due to the ongoing war between Russia and Ukraine, or the invasion of Russia into Ukraine. As you might expect, it has raised quite a bit of international attention on this topic, and I'm going to try to just synthesize some of the key messages from this paper. So what we did is that we focused on the Interact network, which is a network of more than 90 research stations across the Pan-Arctic region, and is the most extensive network in the northern hemisphere. So it ranges ecotypes from tundra, boreal forests, temperate forests, alpine tundra, and wetlands. In an ideal world, I would like to use information from these stations, but this data is not all compiled in the same data set for the analysis that I wanted to do. So in this case, I decided to rely on different type of information. So for this analysis, I use Earth system model data from CIMMYT 6. It doesn't come with a caveat because something that is good about these models is that allow us to infer larger scale patterns so that we can compare information from all these sites, but also has the component of being able to project things into the future. So we use an ensemble of 8 different Earth system models. We also included access from here from Australia, and we look at 8 different essential variables. Here I'm just gonna go through a few of them, but yeah, all these models come with different spatial variability and also some biases in terms of model performance as you can expect. So this is just some examples from precipitation, biomass, soil organic carbon as well. And so what we did was apply simple comparisons on where the Interact stations are located versus the entire Pan-Arctic region. And we apply the Kolmogorov-Smirnov test that checks the maximum difference of the cumulative distribution functions between the Pan-Arctic region and the pixels where the Interact stations are located, both including and excluding the stations in Russia. And we regarded the D values below 0.05 as lack of representativeness. And we applied this for all the models and for all the variables. This is just an example of air temperature that I showed before. And so just to digest a bit some of the key results, because this is not the point of this talk, here what you see is air temperature, precipitation, vegetation biomass, and net primary production. So in the maps, you see the variability of each of the variables, including the Polarin stations, and the red ones are highlighted where are in Russia. So if we look at the box plots, we see that overall the Interact stations are has more warmer temperatures, higher precipitation, and also lower biomass and lower net primary production, also lower soil organic carbon. Of course, when we remove the stations from Russia, these biases increase substantially. This is more obvious when we look at the D values. With the D values, whenever we have a higher value means that these biases increase. And what was interesting, and that was one of the key elements of bringing the modeling, that we can also look at the future. So in the gray ribbons, what I also estimated is the expected variability by the end of the century due to climate change. And we see that for some of the variables, like for example, precipitation and biomass, these differences are of the same and similar magnitudes as when we remove the stations in Russia. So this is already pointed to the fact that missing half of the land mass of the Arctic region has severe consequences on our view on Arctic change. This is even more obvious when we look at this simple figure, just counting the number of stations in this region. When we exclude the ones from Russia, we are severely, almost halving the coverage in the Boreal region. And this is not trivial because the Boreal region includes insane amount of carbon storage, both above ground and below ground. So this has like enormous consequences in terms of carbon cycling, but in many other respects. So after this paper, we draft some future perspectives which became already present perspectives, because this is why I am here in a way. So we have the possibility here to expand this analysis with more data, not only terrestrially speaking, but we can also look at the marine domain and also the atmospheric domain. And so in this paper that I was talking about, we only utilize air system data, air system model data. But now the game is to also include in situ data and remote sensing data. And someone is calling here? Okay. So in a way, I can see this framework as a possibility to knowledge and have an understanding about potential biases and identify gaps, and so that we can inform, for example, station managers about which variables can be measured and where, and also to researchers, so that we can tell which variables are we particularly misrepresenting, so that we can say, okay, we need more information in this particular station. And also, why not policymakers, so that we can initiate a well-informed management and conservation initiatives. And in this context, I am going to bring again Polarin, that is the, so Dan gave like a good overview about the project. What I like about this project compared to Interact is that we are now focusing on marine systems as well as Antarctica. And one of the tasks that I have in this project is to try to identify knowledge gaps to create challenge-driven calls for Polarin transnational access, so that researchers can go to the field to get new data to try to fill some of the gaps that we currently have. And so what we want to do and how is to not only look at in situ data and not only remote sensing or upscale products, but also include the model data that I've been talking about before. So in Polarin, there are 7 themes which are listed here, from sea ice and oceans, ice sheets and sea level, carbon and permafrost, ecosystems and biodiversity, atmosphere and chemistry, paleoclimate and humans and global change. In this presentation, I'm going to just focus on 2. This is just preliminary work and ongoing process. But of course, yesterday I could listen to quite a few of these key essential variables that are good candidates to be included in this analysis, like, for example, ice thickness and etc. So here you have 2 examples. First of all, in the upper panels, we have plant biomass. In the below one, we have soil organic carbon. And so there are two sets. You have the CIMIT 6, which is what we already did in a way. And we also included remote sensing and upscale model data for the same variables. So we are already including one layer more of complexity. The X's in blue represent the polarin stations. And in orange, now we have in-situ measurements from different papers that I found relevant for this purpose, that are all integrating the data set in the same place. And so we see that already the data, in-situ data, is more or less in the ballpark of the remote sensing and model, but we see some discrepancies. For instance, in white, the box plots, we have the Pan-Arctic domain versus the polarin sites in blue. And we see that even though we have similar medium, we have like a lower range of variability. So that means that we might need some more data on a specific size, but we still don't know in which ones. Also, we see that in terms of soil organic carbon, we have typically an underrepresentation, lower values of soil organic carbon compared to the entire Pan-Arctic region. So this is something that we need to think about. And so what we are trying to do is go one step further in this type of analysis. So here what we are plotting is, in these PDFs, we have in black the Pan-Arctic domain, both for remote sensing and the Earth system model data. And then the PDFs in orange include the in-situ data. And so I also included the ticks in blue, where the polarin stations are located. And whenever we see that the orange line goes below the black line, means that we are underrepresenting the Pan-Arctic domain data. And therefore, we can also look at which stations fall within this range, both in this case, above ground biomass. And we can tell, for example, researchers that we need biomass in Olanka and Palas with high biomass, because we are not understanding this variable. And we did the same here for soil organic carbon. Also pointed to the fact, if you remember, that we were underrepresenting soil organic carbon, so we have quite a few stations that might allow us to fill some of the gaps. But this is still an ongoing process. Also, just right before I arrived here, and here I'm going quite a bit outside my comfort zone, but this is just an example of chlorophyll A in the marine system. I use a product from CCI, chlorophyll A, and I also overlay some data. I didn't put here the reference, but it's from André Valente et al. 22 from Earth System Science Data. And so what you can see here already is that we are covering quite well some of the areas in the marine system, but we are misrepresenting quite a few, for example, in the Arctic Ocean, as well as in the Southern Ocean around Antarctica. So the next step here would be to overlay the shipping routes from polarin, which we don't have yet, but I would like to include in this analysis, so that in a way we can also inform for future campaigns where they might want to go. So this is a bit of the rationale of this type of analysis. So just to conclude, we have an opportunity here of utilize this polarin infrastructure that is supported until 2029, which allow us to enable upscaling analysis, and not now only terrestrial, but also atmospheric and marine, blending different methods, field data, remote sensing and models, and also across the bipolar regions, so Arctic and Antarctica. And why I'm here is because Antarctic expertise is essential to test and expand this framework globally. And in a way, your data sets and knowledge can help to co-create challenge-driven calls to shape future sampling campaigns and variable choice. So I invite you to join us in co-designing upcoming gap analysis with new essential variables. Here I just presenting few examples, but the possibilities are endless. Please share your data. I already could learn a lot today and also yesterday about beautiful data sets that are already available. But of course, living in Denmark and working in Greenland is quite far away, so I actually needed to come here and see it myself. And of course, you are more than welcome to join upcoming high-impact papers. So of course, we can come up with a new Nature climate change papers on panpolar bias quantification. And of course, join also like this big gang of universities and institutions working on polarin. And with that, I would like to say thank you very much, and really looking forward also to add more nice pictures from Antarctica in this slide. Thanks.
Thank you so much, Efren. Do we have questions in the room? Oh, sorry, Mark.
Fascinating work. Thank you. I definitely need to read the paper. I was having a hard time keeping up. Just a question of clarification. At the beginning, you were showing model results with and without the Russian stations. Mm-hmm. So are those Russian stations still producing data today that's accessible?
I would like to believe that yes. The problem is that from an European context, we are not allowed to share data. I am in another EU project where we have Russian partners that we got the EU project funded, and they were forced to withdraw after getting the money. Right. So I hope that the data is still.
But you don't have access to it now.
No.
Okay.
And in a way, we have been pushed away.
Right.
From Russian community.
Okay. Yeah. Thanks.
Thank you. Any other questions? No. Oh, I'm just not turning the right way. Here you go.
Just regarding your work that you're thinking of doing with chlorophyll in the ocean, are you familiar with the biogeochemical Southern Ocean state estimate and the work around that? So Matthew Maslow has kind of used that in the past and I don't know if he's still doing it, but has the idea of, he has used it for kind of justifying the SEALS observation network to monitor chlorophyll and temperature and salinity and stuff like that. And yeah, I find that work super interesting, and it's essentially what you're aiming to do as well, or have started to do, because you obviously have to think about the fact that the ocean moves and changes over time as well, so it's a bit more complex. And there's actually a working group within SUS called the Observing System Design Working Group, and it's a very small working group, but there are some interested people there trying to work in this space as well, so it might be worth joining and connecting up that way too.
So thank you for pointing to this, and really I am very interested in teaming up with these two groups, because as I said, this is, I work with greenhouse gases, both methane and CO2 fluxes terrestrially. So this is really outside my comfort zone. I can see chlorophyll as what we measure terrestrially with NDVI. And I also understand that there are like multiple layers of complexity, because we are measuring chlorophyll at the surface, but there is like this vertical component that is quite difficult, and I guess that remote sensing is not even to catch.
Yes, and in all three data streams that you mentioned, the uncertainties change as well, and the actual response of chlorophyll versus biology changes too. So yeah, it's super complex, and I did an entire PhD on it. So
let's talk with a beer later.
Any other questions for Efren? No? Anybody online? Last chance? Okay, well, thank you so much, Efren. That was great. Please, another round of applause. Thank you.